If you are planning to go for a solar power generator for your home, then you are in the right place. As because in this video, I am going to show the various photovoltaic component involved in the solar power generator to power entire house. Hello professionals, Devashish here for RenewSearch. For the past 7 years, I have been helping household get their house set and to be able to survive a loss of electric grid. And here in RenewSearch, we are primarily doing a solar power, renewable energy, battery backup and everything related to the green energy. Now on today's video, we are going to see what are the PV component involved in the solar power generator so that you can get some reference idea while buying a solar power generator for yourself. As you know, solar energy system is divided into three types: off-grid system, on-grid system and hybrid system. We have discussed this in detail in the previous video. You can go through it by clicking on the I button, or we'll put the link in the description below. So let's start with a basic component of solar power system, that is off-grid and on-grid. The first is a solar panel. Solar panel are most important part of the solar energy system. It converts solar energy into electrical energy. A solar panel consists of series of solar cells, typically made up of silicon material. The solar radiation incident on this cell is converted into DC electricity by photovoltaic effects. The output power of the solar panel is given in watt. Generally, with proper maintenance, solar panels have a lifespan of 25 to 30 years. Now let's look after the common types of solar panel available in the market. First is polycrystalline solar panel. They are actually multicrystalline and require generally more space. They are less efficient and cheaper compared to monocrystalline cells. And currently it is the most commonly used solar installation technology across the world. So second is monocrystalline solar panel. They are made up of a single silicon crystalline and have a higher efficiency than a polycrystalline cells. They require less area but are slightly more expensive. Third is thin film solar panel. They are very thin and can even be made into a flexible panels. They require a comparatively higher space area and have a low efficiency. So next I would like you to know about the technology that is called PERC technology, which is passive emitter and rear cell, or passive emitter and a rear contact. This technology is currently in use both in polycrystalline and monocrystalline solar cell. These solar cells are made up of same conventional silicon wafer or the top side for absorbing the incident photons. The main difference between the conventional and PERC solar cell is the addition of dielectric passivative layer on the rear side that helps in absorbing the scattered solar radiation. This additional features helps in converting the solar light into usable electric power even under the low light condition. Okay, let's talk about the second component, which is related to the protection, that is array junction box. The array junction box is one of the most component used between the solar module and the inverter. And array junction box perform functions like, the main function of this array junction box is to electrically connect the output of various solar strings wires in parallels. It consists of blocking diode on each string to protect the this panel for reverse current actually. And the third is it also protect the system against overcurrent and over voltage. So the next is most important component, that is inverter. Inverter is known as the heart of solar system. It helps in converting the produced DC, which is direct current output from the solar panel, into AC, like alternating current supply. Most of the appliances at your home runs on AC supply. Hence, the inverter plays an important role in the conversion of the DC to AC inverters. You know, inverters not only help in the conversion of power, but also help in synchronizing the generated power with the appliances. This is done with the help of conventional transformer based or transferless inverter. Further, inverters are classified into off-grid and on-grid inverters. Now, off-grid inverter is like these inverters works independently and have no contact with the power grid system. And this grid type, these inverter are connected to the power grid system and are most common types of inverter used in the residential applications. So grid inverters are further classified as string inverter. String inverter are in high demand due to their feasible cost and durable technology. In this, multiple strings are connected to build a single string inverter. It also comes with a drawback, that is, if a single strings get damaged or comes under the shadow, it may lead to the performance degradation of an entire inverter. The next one is a micro inverter. As the name indicates, this type of inverter is commonly used where space is the factor over cost. They are most commonly, string type inverter, or in case uneven shading is in small installation, these inverters are placed on every solar panel, thus independently converting DC to AC supply. In this, even one panel is shaded or damaged, the performance of other panels is not going to affect. So next is central inverter. Central inverter is similar to that string inverter with a high capacity range, needing only one large inverter for the entire plant or a section of plant. They are mostly used for large utility scales applications. Hybrid inverter. Hybrid inverters are the combination of this off-grid and on-grid system. They offers a lots of flexibility for the power delivered by choosing between solar power battery backup and the grid connectivity. Next is solar racking and mounting structures. So solar panels are installed either on the roofs or in ground or as an individual pole or mounted array. Installing a solar panel in this area requires proper mounting support. Mounting support not only helps in attaching the solar panel but also helps in positioning the panel at an angle that will provide maximum exposure to the sun radiation. So mounting support is of again two types. First is fixed mount. Fixed mount are stationary and less expensive. This type of mount cannot move with the change in angle of the sun, hence they are less efficient. Second is track mounts. These mounts are flexible and rotate as per the angle of sun. The direction of sun changes throughout the day and track mount can follow that solar radiation, producing the optimum result. They are costly but most efficient as compared to the fixed mount. Track mount require more maintenance and are suitable for large ground mount plants. In rooftop system, we usually consider only fixed mount because the angle at which the panel is placed is optimized on that basis of that location and this latitude, allowing for as much as power to be used as possible from a fixed system. So next is cabling system. Solar cables are considered as the blood vessels of the solar installations. They are responsible for the flow of electric current from panel to the loads through the inverter. It is important to determine the correct solar cable to ensure the system does not overheat and has sufficient current carrying capacity while keeping these prices low. The size of solar cable depends on the solar panel electricity and the distance between the solar system and the loads. So cables are also classified into two types. First is AC cables. These cables are used for connecting solar power inverters to the grid through other protection components and deliver power, AC power from the inverter to the grid or load. Second is DC cable. These cables connect the panels to each other and to the inverter and deliver the DC power generated by the solar panel to the inverter. These cables are used outdoor and hence should be insulated properly also. Next is distribution box. Distribution box or distributional, this panel is the component of electricity supply system. It is commonly of two types. First is DC distribution, which frequently we call this DCDB. It is used for the connecting the output power from the solar panel to the input of that inverter. Additionally, DC surge protection devices may be connected with the DC distribution box to provide any fault against the systems. So next is AC distribution box, which we commonly called as ACDB. It distributes the electrical power from a solar inverter to the AC load system through an energy meter actually. ACDB consists of additional protective equipment such as a circuit breaker, surge protector for disconnect the solar system from the load side supply in case any failure happened. So next is meter. For a grid connected system, energy meter plays an important role in the tracking of amount of energy generated and utilized and sold to the utility grid. Generally following at the three types of meter are used in solar energy system. First is PV meter. These are connected in series with the inverter of the solar system. These meters takes into account the energy generated by the solar panel. First is load meter. It connected on the load side of the note that energy consumed by the different loads. Second is net meter. It is connected between the grid and the solar distribution panel. They are bidirectional meter that helps in monitoring the supplied and consumed power to and from the grid. PV and load meter are unidirectional meters and the net meter is a bidirectional meter. So 81 is protection device. Due to the direct and indirect lightning and other fault conditions, components of the solar system may get damaged. To protect the solar system from these damages, protection device such as surge arrestor, circuit breaker, grounding methods and other safety devices are installed. So this is all about here this component all about in the off-grid system. Next some additional component are there in off-grid connected solar. Off-grid system requires some other components in addition to this essentials component described further. First is energy storage battery. For a grid system or any standalone solar system, energy storage plays an important role. Energy is stored in the battery during the daytime when the solar panel generates electricity and supplies power during night times or in cloudy weathers. Battery used for solar system undergoes frequent charging and discharging, hence rechargeable batteries are used. So batteries help us to reduce the dependency on the utility grid, thus saving the cost this required to buy this electric power from the grid. So again the types of battery we are going to use in this solar power system. These are of two types commonly used in this solar power system. First is lead acid batteries. These batteries are cheaper and less efficient like compared to the lithium batteries. The depth of discharge is almost 50%. So lead acid batteries are recommended when cost is the criteria and power requirement is less. Second is lithium batteries. Lithium batteries are costlier, but they are proved to be more efficient, almost 90 to 95% than this lead acid batteries, and are maintenance free. And the date of discharge of this battery are almost 80 to 90%, and they are recommended for solar street lights, solar powered vehicles, mobile battery banks, etc., and the solar power system also, where this is requirement of regular uses and deep discharge. So we have gone through this deep discharge term. So what is this deep discharge term? Depth of discharge means the actual amount of energy that can be withdrawn from the battery. The section of solar batteries plays an important criteria. In this battery section depends on factors such as daily uses of the load, efficiency, and the lifespan of that battery. The second is a charge controller. It is responsible for determining the adequate amount of charge to be withdrawn and supplied to the battery. It plays a very vital role in improving the efficiency of that battery bank by protecting it from overcharging. Types of charge controller. First one is simple one or two stage controls. Second is pulse width modulations, commonly known as PWM. Third is maximum power point tracking, that is called as MPPT. Some other optional components are also there. These optional components may be added to the system as per the design requirement. First is backup generator. It is not an essential component, but a good choice for places where continuous power supply is a must, like hospitals. Automatic generators are configured to start automatically when solar power or backup power is shut down. The transfer switch is used for switching the this power between the generator, that is nothing but a diesel generator, and solar panels as per the need, either manually or can be configured to automatically switch as per the set conditions. So next one is load center. AC or DC load center consists of a circuit breaker, fuses, and other required switches like a panel board, or it helps in regulating the voltage and current as per your load requirement in the house. So hope this has been the components of solar power generator to guide you to purchase the proper solar product to protect your home from a loss of electric grid. As always, if you find the information here useful, make sure that you can click on that like and subscribe button, and of course make sure you share this link to all those that you think will benefit from it. Well, as always, I am Devashish, encouraging you to get prepared and to be empowered. Thank you for watching, and I will see you again soon. Be safe, take care of yourselves, and take care of your families. Thank you.